Good morning, guys. So our topic for today is to do curve sketching. So what we're going to do is we're going to try and take all the information that we've learned about the first and second derivatives and use that to help us sketch a graph of f of x. Now, we don't have an equation for it, so we're not really looking for perfection. We're just trying to get the general categories and shape of the graph. And there are a couple different things where this will happen. One is this first example where I give you a table. So, okay, here's what we have about this function. The function f of 0 is 0, f of 10 is 12. The function is continuous, and then we have this information about the derivatives. So this is like at x equals 0, this is what's going on, and this is on the interval 0 to 4 and the interval 4 to 10. Okay, so let's see what we have. The way we're going to do this is by having some starting point, and in this case we have 2, right? We have 0, 0, and then we have 10, comma 2. So I'm just going to begin by graphing those there and there. And then what I'm going to do now is I'm going to break it into intervals. And on each interval, I'm going to try and think mostly about increasing versus decreasing, and then concave up versus concave down. All right, so on the interval, that should be 0 to 4. Oh, yeah, no, that's good. So the first interval we look at is 0 to 4. Okay, on 0 to 4, my first derivative is positive. So that means that f is increasing, again, because the first derivative is positive. We also see that the second derivative is positive, so that means that we're going to be concave up. So what we'll do is somewhere between 0 and 4, we're going to sketch a function that's increasing and concave up. And there's no one right way to do this. It's totally possible that your graph might go up there. It's totally possible your graph might go up there. Just the general shape is what we're looking for, just increasing and concave up. Okay, so now let's see what's going on there. So at 4, the derivative is undefined. This is a continuous function, so that probably means it's going to have a sharp corner or something. If we look on the interval now from 4 to 10, well, my first derivative is negative, so that means that f is decreasing. My second derivative is still positive, so that means f, is concave up. Okay, so we're decreasing and concave up, so that should look something like that as we approach the point. Okay, now the only other things here is we see we have a first derivative equal to 0 and 1, so we should probably just start with a slope of 1 there, and then that means we end up with a slope of 0, so kind of a flat tangent line there. So again, this is only one solution, and there are other ways, like you could totally draw your graph in a way that maybe it goes up further and then comes down before flattening out. Like there's not just one way to do it. So I just gave one example. As long as you have the increase and decrease in the concavity right, you're going to be in good shape on these problems. Okay, so now let's do the same thing, but on one of those f prime graphs. So here we have just a slightly different piece of information. So again, I give you a starting point, negative 2, comma 2. So let's just go ahead and graph that right away, negative 2, comma 2. And then we're going to use that to help us draw a graph of f of x. So again, this is a graph of f prime of x. So the height is f prime, and of course the slope of this is f double prime. So when we break into intervals, I see kind of 4 distinct sections of this graph. We have this line segment from negative 2 to negative 1. We have the first part of the circle from negative 1 to 0. We have the other part of the semicircle from 0 to 1 where we're going up. And then we have this line down here from 1 to 3. Okay, so now we have these 4 intervals. So again, we're just going to think about, on each one, I'm going to think about f prime, and whether that's positive or negative, and then f double prime, whether that's positive or negative. So again, if we're above the graph, that's f prime is positive. If we're below the graph, my f prime is negative. And again, f double prime is the slope of f prime. Does this graph have a positive or negative slope? Okay, so from negative 2 to negative 1, we're above the graph, or above the x-axis. So f prime is 0, so it's increasing. And then we are a negative slope, right? This f prime function is going down. So f double prime is negative, so that means we'll be concave down. And again, that's because the slope of f prime is negative. So what you have here is you go from negative 2 to negative 1. We are increasing concave down. So I don't know, something like that. And again, maybe you only go up there, maybe you go up there, maybe up there. There's no like one way to do it. We're just trying our best. Okay, as we go from negative 1 to 0, we are now under the graph. We're actually under the x-axis the rest of the way. So my f prime is negative, so we're going to actually be decreasing the rest of the way. Okay, well now from negative 1 to 0, though, we do still see a negative slope. We're going downwards. That means my slope of f prime is negative, so we're still concave down. So let's draw it. So decreasing concave down to 0. All right. As we go from 0 to 1, though now my slope of f prime is positive. So my f double prime is positive. So that means we're actually going to be concave up. So from 0 to 1, we'll be decreasing concave up, so something like that maybe. And then as we go from 1 to 3, again, we're still below the axis, and again we see, though, a negative slope there. Oops. We see a negative slope on this last section as we're going down. So the slope of f prime is negative, so my f double prime is negative again. So we're going to be concave down there. Oops. So decreasing concave down from 1 to 3. Let's see, we're decreasing concave down, so just something like that. So that's just one general idea. Your graph might look a little different. Maybe it goes up more, maybe it goes down more, but the general shape of increase, decreasing in cavity is the important thing. Okay, I wanted to ask this other question. This is something you'll see a couple times in the review. At what x will f have its absolute maximum? So we could just obviously look at a graph and see the absolute max is at -1. But I want to talk about how we can do that with this. Well, let's think about this. My function increases on the interval from -2 to -1 because my f prime is positive there. Similarly, f decreases on the interval from -1 to 3. I should put the closed brackets and be a good boy there. Okay, so if we have a function that increases for a little bit and then decreases for the rest of the graph because f prime is less than 0, like let's picture it. If I start at a point and I go up a little and then I go down forever after that, I hope it's obvious to you that we're going to have that maximum at the turnaround point. My maximum value will be at x equals -1. Because from there, like we increase up to that point, so it's higher than where we started, and we decrease everywhere after the point, so those points will all be lower. So that's got to be the maximum value. So that's just trying to think about this logically and what the shape of the graph is going to look like. And again, thinking about increasing versus decreasing was the way to do that and kind of think about that. Okay, well, thanks for watching, and I'll see you guys in class.